Something is pulsing beneath the moon's surface. And Elon Musk says it's not natural. For decades, we've believed the moon was a silent dead rock floating in space. But what if we've been completely wrong? What if the moon is hiding something ancient, engineered, even intelligent? Why are certain parts of the moon emitting rhythmic signals? Why do advanced radar scans show symmetrical structures beneath its crust? And why did Elon Musk, a man known for his calculated risks, hint at artificial architecture without ever saying the word alien? The moon's hollow secrets. For decades, the moon was seen as a dead rock, a relic from the solar system's violent past. But recent data from SpaceX's latest Starship probe has shattered that assumption. Elon Musk's team deployed advanced scanning systems, quantum resonance mapping, deep penetration radar, and AI-guided sonar during a full orbital flyby of the moon. What they discovered beneath the crust stunned even the most skeptical scientists. Symmetrical voids and chambers arranged in patterns too precise, too regular to be natural. This wasn't chaos carved by impact or volcanic activity. These were vast cavernous spaces with geometric consistency, parallel walls, curved domes, and clean linear divisions. It looked less like a moon and more like the blueprint of a machine. AI analysis revealed alignment across these chambers spanning hundreds of kilometers, suggesting that they weren't isolated anomalies. They were part of a network. Some resembled massive honeycomb structures. Others formed hexagonal modules reminiscent of modern bioarchitecture. But it wasn't just about empty space. The anomalies weren't inert. Deep below the crust, SpaceX instruments recorded rhythmic, localized heat spikes, thermal surges that pulsed with uncanny regularity. These weren't random geothermal fluctuations. They emerged in patterned intervals, much like systems regulating internal heat or perhaps lying dormant until now. The heat signals came from the moon's far side. Regions cloaked in permanent shadow. Not one Apollo mission landed there. Older probes failed mysteriously in these exact sectors. Now we may know why. The heat emissions align with symmetrical void clusters, almost like reactors or containment vaults flickering back to life after millennia. Some areas even emitted harmonic vibrations when the probe passed above, suggesting that the moon wasn't just responding, it was reacting. To validate the findings, SpaceX dispatched a specialized lander to the South Pole. Drilling teams targeted one of the less hazardous depressions along the rim of a perpetual shadow basin. After descending 90 m through jagged regolith, the drill struck something no one expected. A layer of ultra-hard metallic alloy. The moment it hit, the ground echoed. Not cracked, not crumbled, echoed. The sound it produced matched the eerie ringing heard during the Apollo 17 seismic experiments. The same moon ringing like a bell effect that was dismissed for decades as mere poetic exaggeration. Except this time the ringing had harmonics, structured waveforms, resonant patterns that could theoretically carry information. Spectrographic analysis of the alloy floored Musk's engineers. It wasn't just metal. It was engineered. The material contained rare earth elements arranged in a crystalline lattice similar to what's used in today's most advanced quantum computing chips. No known natural process could have forged this composition inside the moon. The implications were staggering. If this layer was manufactured, then someone or something had constructed it. The moon might not be a satellite shaped by impact, but a vessel, a structure, a device, and we had just scratched the surface. Suddenly, the moon wasn't just a celestial neighbor. It was a question, a riddle buried in dust and shadow, a monument to a history no human textbook had ever dared to include. If what lies beneath the moon is engineered, who or what put it there, the next discovery could change how we view human history itself. Signals from the deep. As if the revelation of symmetrical voids and engineered alloys beneath the moon's surface wasn't enough, what followed next from SpaceX's orbital mission was something even stranger. Sound, or more accurately, a pulse. A slow, steady, low-frequency signal that repeated with clockwork precision. Every 143 minutes, the instruments on board SpaceX's probe detected a deep frequency emission, then silence. Exactly 24 hours later, the cycle began again. This wasn't a one-off glitch. The readings were consistent across multiple instruments and confirmed by external observatories. These weren't geological tremors or magnetic hiccups. They followed a rhythm, one that suggested purpose, not randomness. In natural systems, patterns emerge, but rarely with such mechanical precision. The cadence of the pulses mirrored communication, structured, deliberate, and unsettlingly precise. Engineers decided to take a radical step. They converted the electromagnetic signals into audio frequencies, compressing the time sequence and boosting amplitude for analysis. What emerged was chilling. Harmonics layered on top of each other in ascending sequences. When slowed further, the tones began to sound eerily familiar, not in content, but in form. Audio engineers noticed the signals had structures resembling speech patterns, formants, and intonation curves that are common in human languages. Curiosity gave way to expertise. SpaceX forwarded the audio data to linguists and phonetic analysts across major universities. What began as an acoustic anomaly quickly turned into a linguistic puzzle. Certain segments mirrored the spectral shape of known phones. Those fundamental sounds that make up spoken language. And not just any language. Several shapes lined up with rare Sumerian phonemes. Some used in the earliest known human texts. It wasn't just one match. It was multiple. And while skeptics argued the similarities could be coincidental, the frequency of the overlap grew with each segment analyzed. Then came the most startling development yet. Deep learning models trained on ancient and extinct languages were given access to the raw signal patterns. These models weren't looking for exact translation. They were scanning for symbolic logic, structure, repetition, and order. The result, symbolic sequences, nested patterns, binary encoded intervals with a syntax. It wasn't gibberish. It wasn't static. Something or someone had embedded communicative order into the signal. While no definitive translation was offered, the AI detected hierarchies of structure similar to proto-writing systems. Think cave paintings that evolved into script. The signal wasn't just repeating. It was evolving in layers, almost like an instruction set. Was the moon speaking? And if it was, who or what was it trying to reach? At this stage, Elon Musk himself addressed the anomaly. He didn't claim it was alien. He didn't suggest ancient civilizations, but he pointed out what could no longer be denied. The moon was emitting a pattern signal that matched no known geological or magnetic phenomenon. He called it the most complex signal ever received from a planetary body. Scientists compared it to discovering a radio station broadcasting from inside a mountain on a planet that was never supposed to have any transmitters. Other experts raised more speculative questions. What if the signal wasn't meant for us at all? What if it was triggered by our probe, like a motion sensor long dormant until we crossed a certain threshold? Or worse, what if it's not a message, but a response? And perhaps the most terrifying idea of all. What if these signals have always been there, too faint for 20th century tech to detect until now? These signals might not just be relics of old tech. They could be active. And what's more unsettling, we may not be the ones they're meant for. Geometry in the shadows. The moon's far side has long been a subject of curiosity, not least because we've barely seen it. Locked in eternal shadow from Earth's view, this hemisphere has often been dismissed as rugged, random, and less significant than the smoother plains of the near side. But SpaceX's latest mapping missions have changed everything. Using synthetic aperture radar and deep penetration imaging, Musk's team revealed something shocking. Geometry. Not the scattered chaos of eons of asteroid impacts, but order design. Across vast stretches of terrain, the radar revealed massive structures and alignments, hexagonal arrangements, perfectly spaced spirals, and grid-like impressions embedded into the landscape. These formations weren't geological in nature. Their angles were too precise, their spacing too consistent. Even more unnerving was their scale. Some of these formations spanned hundreds of kilometers, resembling microchip circuits only magnified to planetary proportions. It was a haunting echo of two vastly different systems. The intricate architecture of modern computing and the sacred geometry found in Earth's oldest temples and monuments. From pyramids to ancient city layouts, these repeating ratios and structures have fascinated humanity for millennia. Now we were finding their analogues on the moon. Coincidence or something deeper? Then came the bursts. As radar mapped these geometric structures, a secondary instrument picked up something even more baffling. Gamma-ray bursts, brief, powerful emissions originating near the moon's equator. These weren't chaotic like typical cosmic rays. They came in triplets. 3 quick pulses, a pause, and then the cycle repeated over and over. The emissions were so precise that they mirrored the cadence of a signal, not a spontaneous burst. More chilling was the source, a patch of lunar surface previously labeled geologically dead, a place with no magnetic activity, no heat variation, and no known reason to emit anything at all. Astrophysicists were stunned. Gamma-ray bursts are usually associated with neutron stars, black holes, or massive cosmic events, not from stable lunar terrain.